My name is Carol Lamichane, and today I'm going to do a visualization on the analytics for 3D urban data. My article of my choosing is going to be the state of the art in visual analytics for 3D urban data. In this presentation, we're going to be viewing the introduction, of course, and the key insights about 3D urban data. Our whole article is mainly divided into what. So what types of data, how these data are used, and why it is used, right? So why, how, and what types of data. Questions that we should be asking ourselves when we do any visualization. Of course, the merits and the demerits of the cases. So what is the plus and negatives of the article? And I'm going to be doing my conclusion. So to introduce, this paper has been written over a 15-year period, and it has evaluated over 175 papers overall, looking at different gaps, challenges, and future directions, also looking at different analytical methods, right? Um, so the key insights about 3D urban planning. The main thing is visualization. We already learned in the first lecture two types of visualization, scientific and information. This not only looks at the information visualization side of view, but also looks at the scientific side of view, looking at the geospatial research, and also it sees what natural urban factors play into account. Like I mentioned, three main things that this article is divided into. Why? So why is it used? Why are we interested in 3D urban planning? What type of data is used? And how is it used for analysis and visualization? So first picture that we're going to be looking at is going to be the thermic layer and the physical layer. I'm going to be talking about each and every one of these in more detail. Like I said, why? So what are the use cases? What are the actions that we can take? And what are the targets, right? Some of the targets that we can do is just look up, browse, locate, identify. They are some of the actions as to why we're taking place. What is going to be the physical entity and the thermic entity, and merging of both, and how are we looking at it? Is it visual encoding? Is it thermic and physical combined? What type of occultation handling are we using? Navigation methods, so on and so forth. So in the picture here, you can see in the red is going to be your thermic layer, which is your temperature, weather, and physical layer, which is your actual buildings and such. So like I mentioned, why, right? So let's look at this. When we look at this, we're going to be seeing use cases. So when I say use cases, are we looking at the sunlight, energy, ventilation, noise? What are the main things? And here you can see that urban climate, which means your wind, ventilation, and your sunlight are the primary reasons. When we look at analysis, we look at what actions have been taken, which is browsing, identifying, and comparing. So comparing it to different things that we can probably use it for, and the distribution is the main analysis target. So we want to see how it's distributed overall. So we go on to why 3D urban data. Why is it used, right? So when you think of a building as a whole, when you see a picture of a building, you just see just a picture. But when you actually evaluate the building, you see the height, the depth, and the volume of the building, right? And why is it important? So why are we looking at all three factors? And some one of it is going to be your sunlight exposure. Let's say you want to have an area where sunlight is more exposed. You want more sunlight in your greenhouse, right? That's when you want to see your sunlight, your climate analysis. So is it too hot, too cold? Is it just perfect? And also for disaster and emergency planning. Let's say there's a location where it's disaster prone. Um, just yesterday in Nepal, we had an earthquake of 6.1, which is pretty high in the Herd scale. So we want to see what type of buildings that can be used. So what? Um, when I say what, so what are the different types of simulations, right? Is it Thermic, is it what? So simulations is pretty much saying how the interactive things play together. How does it make sense altogether? The thermic property, is it uniform? Is it multivariate? So the different methods, the scope, the micro, meso, and the macro. So is it small, big, or large? And what type of physical entities are paid attention to? I mentioned before the red one was the thermic layer. So when I say thermic layer, it's going to be your pollution, your overall environment, which is your air quality, your noise, your heat maps. So, heat, when I say heat maps, not our visualization heat map, but the heat actually. And the physical layer is going to be your buildings, your physical stuff, right? Your buildings are going to be some of your data sources, your buildings, your street topography, your environmental conditions like temperature, wind pollution, which is your thermic layer, and the infrastructure. The article also pays attention to the infrastructure, like transport, utilities. It also pays attention to windmills, to see what needs to be analyzed. And some of the sources that were used are going to be your GIS data set, which is your geographical information system, which is your OpenStreetMaps and your city GMLs, right, which provide the overall spatial data. In addition to that, the remote sensing is also used. So like LiDAR and satellite imagery pays attention to the 3D image structure. Also, your crowdsourced and your censored data, such as your IoT devices that are placed around the city, help with real-time updates for urban planning. Meso, macro, and micro are the physical layers that are paid attention to. As you can see in the macro layer, it's the city level impact, right? The big city, the red and green highlights. The red highlights mean the more affected areas, versus the green area means the less affected areas. When you look at the meso, it's the neighborhood, it's the direct neighborhood. And you can see the red and green gradients, which shows different variations of factors. Maybe one has more cold, one has more hot heat, different variations of different solar and seismic vulnerabilities. And for the micro, it's more specifically just the building. So how much shadow is forecasted upon the building, how much heat is forecasted, how much stress is impacted. If in case a natural disaster happens, is it going to withstand? So these are some of the things why we have to look at the macro, meso, and the micro physical layer. So then we go to how, right? We learned why we're looking at it, because important, because of all the city planning and stuff. What is going to be all your different layers, and how is it visualized? How can it be effectively visualized? Is going to be either through encoding, which is your different visualizations, your layer integration, so different layers, right? Your navigation, is it through walking? Is it through manipulation? Is it just through overall? We also going to be talking about occultation handling. Um, we're going to learn in one of our lectures that with 3D, the main problem is going to be occultation handling, right? Which is going to be too much data at once and it's hard to view. So for that, there are different ways possible, and we're going to be talking about each one of these. The models, the display, how is it displayed, and the evaluation, like what's studied, right? And you can see the case studies are the most studied ones. So when I go back to here where it says thermic and that property mentioned together, there are different ways you can look at it, right? Superimposition, for instance, the very first picture, you can see it's directly overlaying data, right? So you can see the physical layer, which is your buildings, and put superimposition it with thermal layers, and you can see the different structures. Embedded views, here you can see that it places 3D graphs, right? You can see different structures with it, that you can also see the flooding. If this area has a lot of flooding, how can we minimize it? The link views are just different views of interactivity, how different layers play uh, example on each other. Interchangeable, this is how we can see different cities, like we did in homework too, right? We are looking at different cities and also looking at the before and the after of a disaster if it has happened. And juxtaposition is just a data set for multiple views, right? So you compare wind simulation with statistical visualization and you get juxtaposition. So you can just see the dynamics. I mentioned with any 3D data, occultation handling is essential. We want to we want to know that the data is clear and it can actually be understood. So with occultation handling is just a way to make it more clear. A deformation is reshaping the building just to reveal hidden areas. Ghosting is to make one building more transparent than the other. Slicing, you divide it into the vertical and the horizontal perspective and you see a better view. Bird's eye view is just the overall satellite image, like from above. A multi-view, are you looking at the top of the building, side of the building, all overall picture, right? And then your assisted steering is to see the automated view selection, different views, and avoid obstruction. Going on to evaluate, here you can see a huge data of urban setting where its highlighted position shows the solar exposure, how much solar exposure has actually been there. Over here, you can see the different water levels. So you can see the red ones is actually more prone to flooding, and it's a high risk zone versus the blue one is less high risk. You can also see shadows, how much shadow exposure is there. Once again, flooding, which areas we need to be careful of. This is showing your wind flow, how much wind flow is present in that area and how would wind travel perfectly. And D is your hieroglyphics, which we can see in weather maps, right? How the wind moves around and makes it more feasible. So there's some of few questions that we need to ask about ourselves when we're looking at visualization. We talked about this in class in lecture 2. So we're talking about what does it show us? It reveals a spatial relationships. The key contributions are looking at the survey of the state-of-the-art visualization and looking at 3D. The compelling evidences and examples are going to be your study about air, sun, climate modeling. Yes, this could have been done more simply with a 2D hybrid, but it wouldn't be giving us an overall view. Top principle has been implemented because it avoids unnecessary clutter using occultation, and the Gestalt principle also shows how well has visualization been done, and proximity similarities have all been used. So the merits of the article is going to be the comprehensive review. From 2008 to 2023, over 175 papers have been reviewed. Like I mentioned, Jigsaw principles and tough principles, including the thermic and visualization, which separates the different layers. Small multiples and proximity has been used as well. It talks about systemic categorization into why, what, and how. Research gap has also been shown for handling and possible problem areas. Interdisciplinary collaboration, right? So how is everything used together? How the collaboration might work between urban planners and visualizers, and exploration of emerging technologies like your AR and VR for urban planning. So diverse use cases like your shadow volumes, your water simulation for flooding, your airflow, your hieroglyphics. Your city government can also use it for zoning, your sustainability. Occupational handling has been effectively looked at as well. It also provides proper clarity, HSL, which is your hue, saturation, and your lightness, and an effective organization has been used. So the demerits of the article is going to be the lack of empirical validation. There is no exact studies done. Studies are still in process. Potential biases are present, as with most papers. It only focuses on visualization venues and misses a lot of border research. It has challenging efforts for practical implementation because there's not concrete solutions yet. It doesn't talk much about ethics and privacy because when you're looking at somebody's house, you want to be aware what areas are you actually looking at, right? Are you even allowed to be in that area? Complexity of visualization techniques. How difficult is it to look at it? Some of the techniques are high end computing, which is not cost effective and also provides limited accessibility. Lastly, poor data and density and chart junk are present as well because when I showed you the image of superimposed, right, the building and the thermic layer, that can provide some chart junk because it's not a clean data. You really need to look into it. 3D visualization matters. Um, why? Because, like I mentioned, you can do so much with it. With 2D, you just look at a building. With 3D, you can look at the several layers, see how energy effective it is for disaster management, so on and so forth. For real world urban applications, you can see where do you actually want to make these buildings? Where do you want to see the airflow? You can also use for FEMA disaster relief, right? And the future works, a lot of future work still needs to be done based on the article because refining navigation techniques and improving uncertain visualizations need to be done. But overall, the article has shown really good and promising work about 3D urban data. If there are any questions, please let me know. Thank you so much for your time.
Well, thank you. That slide with kind of what the visualization elucidates, Tafti principle, and all that, it's fine to use with one visualization, but I think in this case, there were lots of visualizations. So it kind of, unless you go and look at, so it's really meant for a single one, not for multiple ones. And if there's, I heard something like 100, some change there that they look at. Maybe I misunderstood. But then that's quite a lot. Yeah, obviously, I don't expect that to go over.
All
So
right.
it's mostly, I was looking more for merits and demerits in general, rather than that particular one. But other than that, you kind of, I'm not sure if on every time we use a map, it's kind of hard to display. There was one of them that had some bar chart next to it. That was the only one that kind of caught my attention. It's kind of hard to display the bar chart or a lot of kind of more patterns in the data together with the spatial pattern. So that those of you who would try that for the project will notice that it's not an easy task. So trying to stick with 2D or 3D or existing layout and superimpose on it more data information kind of things to show correlations and things like that, like i.e. homework 3 or homework 2, it becomes tricky. And that's where people have tried so many of these articles or so many of these solutions that this article talks about. So that's pretty much it. Thank you for the presentation.